Hey everyone, we're back with our Docker Quick Start class. And the first thing that we're going to do is we're going to install Docker. Now today we're going to be installing it on a Linux CentOS cloud server that's available here for you to use at Linux Academy. However, you really can install in any environment, whether that be your Linux desktop or even Ubuntu. Now I'll have a guide written up on how to install Docker through Ubuntu, and I'll ensure to share that in the link of the description of this video. So regardless of what operating system you're going to be using, you're really going to follow the same format. Now I'm going to do these videos really focused on the command line and at our diagram. However, I am going to pop up every once in a while and explain important concepts to you. So with that, go ahead and spin up a cloud server and follow along. So the first thing that we're going to be doing is we're going to be SSHing into one of our cloud servers provided here at Linux Academy, and we'll be using the cloud user. Now, as the demo gods go, I always seem to get the password wrong the first time. So we're just going to go ahead and clear that away, and let's give a shot at looking to see what operating system we're using at. So for today's example, we're going to be installing on CentOS. As mentioned before, there will also be a guide on how to install through Ubuntu. One of the first things that we're going to do, though, is ensure that we have all of the packages that we needed in order to be able to install Docker. This is going to include your yum-utils package, device mapper persistent data, as well as LVM2. As you can see, if you're using a Linux Academy cloud server, these packages have already been installed. However, it never hurts to ensure that they have been installed before proceeding. The next thing that we're going to do is we're going to add the repository that we need in order to install the version of Docker that we're going to be using. Now, the URL in order to download Docker always makes me laugh because it's very intuitive. You just go to download.docker.com/the operating system which you're going to be using, which is Linux, /the version of that operating system, CentOS, /docker-CE for Community Edition, and EE for the Enterprise Edition. .repo. We're installing that repo. Once we have that repository configured, all we'll need to do is do a yum install docker-CE, once again for the Community Edition, and -EE for the Enterprise Edition. Now, it's always good to remember that this is a privileged command. As we start going through our install process, the first thing that we're going to pause on is asking whether we want to install Docker CE as well as Container SE/Linux. Now, if I know some of you that are following along, you just added a -y flag and let this go through. But I think when you're first installing something, it's important to pause and see what is it that you're actually installing. If you're unfamiliar with it, Container SE/Linux are simply the policies for container runtime within a Red Hat environment. So that could be your Red Hat, your CentOS, your Fedora environments. We'll go ahead and say yes here. Then we'll move on to our GPG keys. Now, as we did not already have Docker's GPG keys on our system, I went ahead and retrieved that key, and now it's importing it and then asking us, are you sure that this is the correct GPG key? If for some reason we were not, we could go ahead and check in Docker documentation to ensure that it is. So we can go ahead and say yes. So as it installs these packages, primarily your Container SE/Linux policies, it is going to take a bit of time. So through the magic of visual editing, we can go ahead and shorten that time for you. And now our packages are installed. So let's go ahead and enable Docker. As well as starting Docker. Now at this point, Docker is installed, enabled, and started on our system. This means we can go ahead and use it, right? Well, not quite. Let's go ahead and clear the screen so I can show you what I'm talking about. Now I'm going to be using the command sudo, and we'll address why in just a moment. So we're going to do sudo docker run and the container that we're going to be running is called Hello World. Now we're unable to find this in our system as this is a brand new Docker install. So it's going to go ahead and pull that from the Docker library. And once this has been completed, it'll go ahead and run. And as you can see, this container is simply a small Docker image that shows that your installation has worked correctly. The fact that this container ran proves that the Docker client was able to contact the Docker daemon. The Docker daemon was able to pull the Hello World image from that Docker hub, and the Docker daemon was able to create a new container from that image, which produced the output that you're seeing on your screen now. The Docker daemon was able to stream that output to the Docker client, which is what sent it to your terminal. This is a great image to show how exactly the Docker image ran, and we are going to be digging deeper into this process. But the reason that I said, you know what, we're going to go back to that sudo command is the fact that I ran that as a privileged user. What would happen if I tried to run this command as simply our cloud user? Let's go ahead and try that by clearing our screen. So we do our docker run hello world, and suddenly we have permission denied. That's because our cloud user does not have the permissions to be able to use Docker. And so we can modify this or correct this issue by adding our cloud user to our Docker group. Now, although there are ways to get around needing to log out and log back in, when you make these fundamental changes in a Linux environment, it really is best practices just to log out of that user and log back in order to ensure that all the environmental variables and changes are read. Now that that's occurred, let's go ahead and try that command one more time without sudo. Now I will have you notice one difference. When I ran this command, we're no longer needing to pull that image from the Docker hub because the image already exists on our system. Okay everyone, as simple as that, you are now up and running with your own Docker environment. Now, technically, I guess we did cheat a bit because we did run our first container. So in order to understand how you did that and to continue using your environment, let's go ahead and close out this video and continue on with our journey. Hey everyone, it's El Marquez again, and if you're following along with our Docker Quick Start Guide, I'm sure at this point you're wondering, is she telling me the full truth? Do we really need to go through this extended Docker install every time I need a new environment? All right, you got me. That's not the only way to install Docker, but that tends to be the truth with anything in Linux, right? There are multiple ways to do something. So as you can imagine, many system admins and other developers got tired of going through this process every time. So now that you've gone through the longer, more entailed process of installing Docker, let me show you how to do it through a scripted method. So here we're logged into our cloud server, and you can see that we're going to be using the wget command in order to pull the script onto our server so that we can install Docker. This script is provided by Docker at get.docker.com. However, you don't blindly want to run scripts on your server. Of course, you're going to want to see what's actually located or composed of this script. So let's go ahead and go to that URL. And you can see here what commands this script is going to be running. It also states that if you want to make sure to verify the contents of the script, you can do so on Docker's GitHub. However, as this is a quick start, not a deep dive, let's go ahead and go back to our command line and see the script install. Now I'm going to go ahead and jump in here for a second and do a little truth in advertising maybe. That's because sometimes this GPG section really does take a while to happen, and I don't want you just sitting here staring at this screen. So I'm going to go ahead and edit it down through the magic of video editing. So you may need to pause this video and allow the installation to continue. But once we are up and running and installed, it runs just like our other Docker environment. We'll go ahead and add our cloud user to the Docker group so that we can use those privileged Docker commands. But we seem to have a problem here. It says that Docker is unable to connect to our daemon. That's because though we did do our install process, we've not gone ahead and enabled as well as started the Docker daemon on this system. So do so, but remember to use your sudo command, as this is a privileged action to be able to run a service on a server. Now, once we've done so, though, we still can't seem to use those Docker commands. And that's because we'll need to log out and log back into our server to ensure that our permissions have been read by the system. Let's go ahead and do that. And once we've done so, we can go ahead and use commands like docker version, and we're ready to go. So now you know how to install Docker on Linux in two ways. One being the more extended version, but I really would encourage you to take the time and learn that before just automatically opting to use a scripted version. Go ahead and close out this video, and we can continue on learning more about Docker. Hey everyone, it's Elle Marquez with linuxacademy.com, and today we're here to talk about the Docker Hub. So if you've been following along with our Docker Quick Start series, you have Docker up and running. And in fact, we did cheat a little bit and we went ahead and ran our first container. But how did that happen? Well, the way that it happened was that we pulled down an image. What I didn't really address is where this image was coming from. The image that we pulled using our standard install of Docker came in from the Docker Hub. Now, if you are unfamiliar with the Docker Hub, but you do have perhaps a little bit of a tech background, you may be familiar with GitHub. Now, we use GitHub in order to go ahead and store code that we want to share perhaps within our company, perhaps within the world. And GitHub allows us to do this, Docker Hub enables us to do the same thing with our Docker images. Although Docker does enable us to be able to have publicly hosted images as well as privately hosted images. But we'll get to that in just a bit when we delve into actually seeing Docker Hub in action. And behind me, you're going to see two resources. One is going to be the Docker Hub main webpage, and the other is going to be our Lucid chart that I'm going to be using to hopefully be able to show you what's going on. So what you see on our Lucid chart is, first of all, we have Docker. And Docker is the Docker engine which we just installed onto our server. It's what enables us to be able to run these containers within our server environment. Then we add to that the hub, and if you know the term hub, it means kind of the heart or the core of something. So we like to think of the Docker Hub as kind of the heart and the core of what helps Docker run. We pull that together and we have the Docker Hub. The Docker Hub is referred to as a registry. And within this registry, we have repositories. Very similar to when you are pulling something in from, let's say, Red Hat, and you're pulling in from those Red Hat repositories. Well, when you're pulling down an image, you'll be pulling down an image from a Docker repository that's held on the Docker Hub. Now, I did state earlier that this is the standard install because Docker really can work with any hub that's available out there. We have private cloud or public cloud companies that do offer their own hubs, and Docker does enable you to be able to host your own private repository or private registry within your company so that it's not accessible to the outside world. This is great for companies that really do use Docker for proprietary information. All right, that's a lot to handle. So let's go ahead and take a few step backs and let's just talk about the Docker Hub on its own. So in order to use the Docker Hub, you're going to want to have your own account. So let's go ahead and turn our attention to the screen and get that set up so that we can get to learning. So the first thing that I'm going to do is I'm going to go ahead and close out our Lucid charts so that if you're on a mobile device, you're not struggling to see what it is that we're doing on the screen. Now, the first thing that you are going to want to do is pick your Docker ID. Now, please keep in mind that you are more than likely going to be sharing this ID with others. So please remember to keep it to something that you're going to feel comfortable sharing. So if you follow me on Twitter, you'll know that my secret alias is LOPunk, and I'm going to go ahead and choose that for my ID. Then you'll want to go ahead and enter your email address. And choose a secret password. Then you'll want to go ahead and take the time and read the terms of service, as well as your privacy policy and your data processing terms. Now, I know that your first instinct is going to be to skip these, but go ahead and read them, because if you're going to be an active part of the Docker community, this is really going to lay out the foundation to how you're going to be interacting with the Docker Hub. Also remember that, our first instinct is to opt out of getting any emails. However, I have found these emails to actually be valuable when I'm wanting to stay up to date with what's going on with Docker. So I'm going to go ahead and agree to all of these. And then we're going to play the CAPTCHA game. Now I'm going to go ahead and just kind of edit this section out, fast forward through it so that you're not having to watch it. Now that you know that I'm officially not a robot, we can go ahead and sign up. All right, we're almost ready to go. So let me jump back over to my email and get this confirmed, and we'll be ready to start using the Docker Hub. And now I've kind of clipped out some personal information from this shot, but in order to confirm, all you'll need to do is go ahead and click that confirm your email, as well as ensuring that you do this within 2 days. So let's go ahead and confirm that email. All right, it's as simple as that. We're logged in. Now we have the option of being able to create our repositories, we can create organizations, or we can even explore other repositories. This is where I'd like to get started because it's really at the core of how you'll be interacting with the Docker Hub. So as the screen is loaded, you'll see that we have a few different repositories showing up. You see Nginx, Alpine, BusyBox, and underneath you're going to see the tag of official. So the Docker official repositories are a set of Docker repositories that are hosted on the Docker Hub that are designed to offer a few specific use cases. For example, you have your base OS repositories. That's going to be your Ubuntu, your CentOS. And these are there to serve as a starting point for a majority of users. They're going to provide a drop-in solution for popular programming languages, runtimes, data stores, and other services, very similar to what a platform as a service PaaS would offer. They're going to also exemplify the Dockerfile best practices, and I'll show you that in just a second, as well as provide a clear documentation to serve as a reference point for other Dockerfile authors. Maybe that's going to be you someday, so these will give you great examples of what your Dockerfile should look like. They're also going to ensure that security updates have been applied in a timely manner, and this is really important when it comes to being part of an official repository, as they become some of the most popular ones available here on the Docker Hub. So let's go ahead and click on this Nginx repository as it's right at the top and kind of give an example of what this looks like. So this is the official repository for Nginx. You can see that at the top of your screen, as well to the side of that, giving you what command you're going to need in order to pull this image. So on your command line, you would simply type docker pull Nginx. I'm actually going to be using a different repository in order to show you what I think is an amazing example of a way to upkeep a repository, and that's going to be our Hello World image. So let's go ahead and go back and search for that Hello World image. Here we can see the official version of Hello World. We can also see that there are other versions that have been made available to the public, where others have kind of put their own spin on things. If we go into our Hello World repository, we can see the simple command that we ran, docker pull hello world. We can see the GitHub in which to file issues. We can see where we can get help if we're having issues with this image. They'll even show you an example of the output that you'll see if you do a docker run hello world. This looks very similar to what the output should have been when you ran that container through your install process. This is a great example of providing information for a specific image, because they even give you information on how this image was created, as well as licensing information for it. Now, I will say that this is not available through every image, because it's really the image maintainer or the creator that is providing what information they're going to share to the outside world. This is one of my favorite images, however, because of the depth of information that is really put on their Docker Hub page. Now, I do know that this video is getting a little bit longer than any of the other videos in this course. However, I think it's because this is how important the Docker Hub is to your success with using Docker. Even if you're using your own private repository, much of the information is going to be the same and in the way that you interact with it. So let's go ahead and scroll back up and work on creating our own repository. So we'll go over to Create. We'll have the option to create a repository, to create an organization. Let's say that we were working with other developers, or even create an automated build. That's going to be more of a deep dive topic. So let's go ahead and just go into creating our own repository. So I'm going to use this as Docker Quick Start. Then we'll enter a short description. Now you see here that you have a few options for visibility. You have that as a public repository, which means that the whole world will be able to use them. That's what I'm going to choose for us, so that you're able to interact with this repository later on as you're taking this course. And we also have the option to set it private. This is something that I might do if, let's say, that I was working with another course author on developing a specific image to use. However, it wasn't really ready for the rest of the world yet. So let's go ahead and choose public. Oh, hold on, we have an error. It says that we need to enter a valid repository name, which means that we can have no spaces, no social characters. So let's go ahead and get rid of that space. There you go, let's give it a try. As simple as that, we are up and running with our own repository here. So what if I wanted to create an additional public repository? Let's say that we were going to go ahead and start working on that Docker deep dive course. Well, it really wouldn't be a problem. That's because Docker allows you to have as many public repositories as you need to. You can share all your images with the world. However, if you wanted to have more private repositories than just the original one, this is where you're going to start needing to look at different pricing plans available through Docker. So let me go ahead and show you that before we move on. So this is the billing and pricing information, and you can see at this time with our free plan, we're allowed one private repository as well as one parallel build. This is a way to have our builds occur quicker by allowing for them to occur in a parallel manner. I guess that's kind of self-explanatory there, but we're not going to go into that right now. We're focused on our repositories. You also can see that if, let's say, you get a micro plan, you can have up to 5, and up to your extra large, which you can have 500 private repositories. Feel free and play with this on your own, but for now, I think we can kind of get back on camera here and wrap this video up. If you'd like to learn a little bit more, I'd encourage you to take our Docker Certified Associate course, which dives deeper into these subjects. But for now, that's all we have when it comes to the Docker Hub. So go ahead and close out this video and continue on with your journey. Hey everyone, it's Elle Marquez from linuxacademy.com, and today we're going to be discussing Docker images. Now, one thing that I want to ensure that you're aware of is it's really difficult to discuss Docker, just one concept, without pulling other concepts into it. For example, when we did our Docker install, we went ahead and pulled down a Docker image and ran a container from it to ensure that our environment was working. The same thing is going to occur when we discuss Docker images, because we'll need to discuss a little bit of the Dockerfile and running containers. Please understand that we'll go further into those subjects in subsequent videos, and we're really going to just be focused on understanding how we create Docker images and also what a Docker base image is. So I built out a story for you because this is really how I learn. Let's pretend that I work for a development company and I'm in charge of onboarding, let's say, junior developers. Just an example. But I want my developers to be happy, so I'm not going to tell them what type of computer to use. You want to develop on Windows, Mac OS, Linux, whatever floats your boat, you're good. But what I want to ensure is that you're all writing the best code for us to push into production. And in production, we happen to use Ubuntu 16.04. And so what I'm going to do is I'm going to pull in a base image from the Docker Hub, the Ubuntu repository, which is going to be our base image of Ubuntu 16.04. Now I want to make sure that everybody is up to date and running the most secure containers that they can and most secure OS that they can. So I go ahead and I do that apt-get update. Now all of our developers will be coding in Python 3, so I go ahead and install Python 3 as well. What I can do here then is I can take this image which I've created, and just to let the elephant out of the bag, we do so by using a Dockerfile that we'll be discussing in a bit, or we'll be discussing in a different video. So I take this image, which I have then created, and I can push it back up into that repository which we created called LOPunk. Now when it's sitting there, when our new developer comes in and says, all right, hey, I've been hired, how do I get started? Instead of just giving them a sheet of all the things they have to do to get their computer set up the way that we want it to, I can say, you know what, just go ahead and pull down my get started image from LOPunk. That's it, from our LOPunk repository. Then, just to make sure that your environment works exactly the way that we want it to, why don't you write a small Hello World application and then go ahead and push that up to the Linux Academy GitHub so that we can all see that you're up and running. All they would need to do is go in and pull that getting started image. They would go ahead and copy over the files for their Hello World Python script. And then they could push what's essentially become a new image back up into the Docker Hub. Now that's as clear as mud. Don't worry, we're going to be spending the next few minutes together actually going through and seeing what this looks like on the command line. So I'm going to go ahead and get off screen so you guys can focus on that, and we'll see you on the other side. So the environment that we're logged into is the same environment that we did our scripted Linux Docker install. So in order to see if we have any images there, we can use the command docker images. You can see that we currently have no images available, so we could pull one down using the command docker pull. And let's say that we wanted to pull that Ubuntu image. So we could do docker pull, and let's say that we were just to type enter here. Well, then it would pull down whatever image is tagged by Ubuntu as their latest image. Sometimes the latest image might not be the most newly available. For example, if they have an Edge release that perhaps is their latest, however, their stable release is tagged with something perhaps like stable. And if we wanted to pull down Ubuntu 16.04, then we would be Ubuntu 16.04. So Docker pull from our Ubuntu repository the image 16.04. Now I want you to notice that this isn't just one pull. You actually saw multiple pulls occurring as well as multiple pulls having been completed. You can see that we had one pull here, 2, 3, 4. What you're seeing here are Docker image layers. Images on Docker can be composed of several layers. So for example, in this image, once it's completed, we would have our base image, which would now be Ubuntu 16.04. That would be one layer. Our update, which has created a different change on that image, would become another layer. And then Python 3 would be yet another layer. In order to really understand what caused these layers to be created, it's best to really look at the Dockerfile. Now, I'm not going to be spending too much time on the Dockerfile as we'll have its own video. However, I did want you to be able to see what was occurring. You can check out our official Ubuntu image. I go down to 16.04. And I can see the Dockerfile that was used in order to create that Ubuntu 16.04 image. Every change that occurs to this image is going to cause a new layer. So they're saying from scratch, meaning that this isn't based on anything else. We're going to add this file. Then we're going to run this section. Now you might be thinking, well, why didn't that cause multiple layers? That's because they scripted it in such a way that this is really only running one command. You can see that by your and commands here. So that was layer 2. Then layer 3 is going to be the removal of this. Then layer 4 is going to be your make dir change. So now that we have a little bit more transparency to what it is that we've pulled from the Docker Hub, let's take a look at how we are going to be interacting with our Docker image. So let's go ahead and do Docker images again so that we can see the image on our system. And there's a bit of information here. Now I'm going to go ahead and just close out my Lucid chart for a little bit so that you guys are better able to see the information on the screen. Okay, so running Docker image, we see the repository that this image was pulled from was our Ubuntu repository. Now this image was tagged with the version being 1604. Now one thing I want you to understand is that a tag really has absolutely no value when it comes to the image other than what we put on it. Think about tags as one of those labels that comes out of the label maker. You can write whatever you want on it and it just represents whatever value you've put on it. So we could use tags to label version numbers. We could use them to label the person who's created it. You have a tag called maintainer that is a Docker standard for that. So, the tag is going to be L's image. Or we can use tags for separating development from production. Then we have our image ID. Now this ID is used to uniquely identify this image. It's almost like the image's name. Though we can refer to it as Ubuntu, we can also refer to it by its image name to be able to interact with it. So whereas I could run a container with docker run Ubuntu 1604, I could also run the exact same container with the command docker run and the image ID. Now, something interesting to note is that this image ID isn't actually its full image ID. We can add the no trunk flag in order to be able to see the full ID. You can see that it says that it's a SHA-256 image ID. And what it really is a hash, a SHA-256 hash of all the image layers that were created to compose this image. Later on, we can discuss about how this can be used in security to ensure that you are pulling the image that you believe that you are pulling. All right, I wanted to hop back on the screen just to say that I hope that you now have a better understanding of what a Docker image is, of how a Docker image is composed of layers, and how we're able to change what essentially is our base image into a whole new image that fits our needs. For now though, you can go ahead and close out this video and continue on with your journey. Hey everyone, it's Elle Marquez with linuxacademy.com, and today we're going to talk about the Dockerfile. Now if you're following along with our quick start guide, you know that we just talked about Docker images, and honestly it was a lot of beating around the bush trying to figure out how to teach images without delving into this Dockerfile. So I thought, what better video to follow up than for us to go ahead and write our own Dockerfile. What we're going to do is we're going to try to tackle our example that we had here with our Lucid chart. We're going to build an image that uses Ubuntu as its base. Then we'll go ahead and do an update and we'll install Python 3. Now we're not going to go too far into all of the different configuration changes that you can do with the Dockerfile. If you'd like to tackle that, go ahead and follow up this course with the Docker Deep Dive course. But in the meantime, let's go ahead and get behind that command line and start getting our hands dirty. So we're logged into the same environment in which we did our scripted Linux install. If you recall, we didn't pull down any images. So if we do our docker images command, we will see that we have no images on our system. What we're going to do is we're going to create our own image using this as our template. Now you can think of this onboarding square here, just the directory that we're working in. So we'll go ahead and create that directory. You know what? Let's not capitalize that because it's just not good in Linux to have some random capital letters. I'll go ahead and cd into that directory. And I'll create my Dockerfile. Now, you don't actually have to use the term Dockerfile because you can specify what file you're going to use. However, by default, it looks for that Dockerfile. So the first line is going to be that from command. What are we basing this image on? When we saw our Ubuntu image in the previous video, we saw that it said from scratch because they were creating it completely from scratch and pulling in that tarred file. However, we're going to base ours on that Ubuntu 16.04 image. Next, we're going to want to update it. So the command that we're going to run is going to be apt-get update. Next, we're going to want to run the command apt-get install Python 3. I do, however, know that you only really have to do apt install. I'm sorry, old habits die hard. I'm going to go ahead and add that -y flag in so that we're not prompted to accept it. When you're automating something, you really don't want any prompts inside of it because it can definitely break your script. Forgot the word install there. Technically, this is everything that we need. This is exactly what we need to be able to get our onboarding image up and running. There are two things I'd like to note here. One, you see that I capitalize our from and run statements. Although that isn't mandatory and the Dockerfile can run without this capitalization, it's what we call best practices. Next is, once upon a time when Docker first started, there was an instruction called maintainer that was best practices to use. So you'd see an image looking something like this. So maintainer has since been deprecated, and it was really a set of instructions, kind of like an author field, that let individuals know who was maintaining this image. You know, if they had an issue, who should they contact? It's still in use, but the way that it's used now, it's still somewhat in use, but really it's used now as a label. So if you did want to have that maintainer status, you would simply go ahead and use label as your instruction. So that's all we need. We should be able to exit out of this video. Let me give it one once over just to make sure I didn't make a silly typo. We'll go ahead and write and quit. Then we can use the command docker build, be building the image, and I could give it the name of the file I'm going to use, or more commonly, you'll see a dot. That means build using the Docker file that is in this current directory. So we see our build context, which is what we wrote in that file, being sent to the Docker daemon. The first step is to go ahead and pull down that image from the Docker repository because we didn't have it in our library. Let me scroll up here, and we can take a little bit of a closer look. So we saw step 1 of 4 was from Ubuntu 16.04. That's what we told it. It pulled it down from the library, and you see those 4 layers that we've discussed previously. Once it's been pulled down, it does step 2. It adds the label maintainer, and you can see my email address there. Now I want you to note something. It says that this is running in, and it gives an ID. As it's pulling instructions, it's actually creating a container for that to occur in. So we had our pull and we had Ubuntu 16.04 happen here. It then gave us an ID number. I want you to go ahead and note this A51 because it's going to come across in just a bit. Then we had our step 2, our label that ran in this container. And as soon as the instruction adding that label was done, it went ahead and terminated that container. Then we have another container. Then we have another ID here. This is called an intermediate image. It's an image layer that is created and kept in cache, but it's only kept long enough for this build process to occur. It is not an image that you would have access to. So step 3 is to do that run at get update, and that goes ahead and occurs inside of another container. We see the update occurring here, and as soon as the update is done, it removes the container and we get another one of those intermediate image layers. Step 4 goes through the install process of Python 3, which is run in its own container. And we work our way down. Once the instructions have completed, that container goes ahead and is removed, and we get our new image ID. Now, if you notice, the intermediate image layer is the same as our final build number. That's because this is it, you're done. This is not an intermediate layer, it is your actual image. We can prove that by doing your Docker images. And here you see, your image ID is the same as what was built. Let's go over it one last time with our Lucid chart, as it might make it clearer. So we had right here, we sent the context to the Docker daemon. That's what was inside of our file. And step 1 was from Ubuntu 16.04 to have that image pulled. That would be this right here. And then I decided to add something a little bit different here, and that's because we went ahead and did our label maintainer. From there, we went ahead and did our run at get update. That's going to be here. And so there was a container 962b was created with this base image, and an update was run. When that update was completed, the container was closed. So it removed that container. Then a container was spun up with that intermediate image, being the Ubuntu 16.04 that had been updated. There was an intermediate image, which was this right here. A container with this image layer was spun up, and Python 3 was installed. Once that was completed, that container was removed, and what was left, which would have been this image layer here, was our actual layer that we would keep. Although we had an image layer built here and here with our maintainer label, those were simply kept in cache, and as they weren't what we requested, they were not kept on the system. But if this is the case, then what's this image here? Well, it's our Ubuntu image, which we pulled down from the Docker Hub in order for us to be able to create our new image, because it's what our new image was based on. Okay guys, that's it. That is how you start out by building your own Docker images. Hopefully right now you're feeling a little comfortable with the concept, and I'd encourage you to stick around after this video if you followed along with your own environment and build out a couple of different Docker files. See what changes you can make and how that changes the resulting image layers. And just have fun and get to know your Docker environment. For now though, you can go ahead and close out this video and continue on with your Docker journey. Hey everyone, we're back with our Docker Quick Start course, and now we're going to discuss actually running containers. Now if you're saying, Elle, you've been running containers this whole time, all right, I did cheat a little bit by running container to show you how to tell whether your environment was up and running. I kind of showed you our hello world image by running that container. Don't worry about it, there's a lot more to running containers. In fact, we don't have to just run an image that spins up, puts out some output, and then the container closes. We're going to be creating containers that are meant to last for a little bit. Now don't get me wrong, containers are meant to be ephemeral in nature. This means that they are meant to kind of just come up, do the job that they need to do, and go away. However, when you're developing, at times you need these containers to last a little bit longer so that you're able to tell whether your code is working, how your application is being maintained. That's what we're going to be covering today. We're going to be creating a container from our Ubuntu image. We're going to be going into it and exploring the environments a little bit, seeing how we might use it in a testing environment. And I'll kind of delve into a little bit of some groundwork that I've been laying for you. You see, this whole time we've been using the command docker run, but Docker's been growing. There's a lot more to the product, so I'll introduce you to the command docker container run and discuss a little bit about why that change was made. So I'm going to go ahead and disappear so we can get to the real meat of this subject. And we can see what environment we're logged into by doing our Docker images. And you'll see that we have two images. These are the ones that we used in that Dockerfile video. Now, please note that we haven't added a name or repository to it because we'll be doing that in a subsequent video. We're building a story here together. Another thing to note is that it's time for us to build on the commands that we've been learning. Now, we've used that Docker images command throughout the course, but let me introduce a new command to you, and that's docker image ls. As you can see, it does everything that the command above does, Docker images. However, as the community has grown, as the Docker community has grown, they've moved towards using commands that really give you information about what you're interacting with. It's very similar to when I built this image. I did that apt get install Python 3, even though all you really needed to do was apt install Python 3. Though one command may be legacy, it's still available and still works. So why have I spent all this time teaching you that Docker images command? Why didn't I start out with the docker image ls command? That's because as information comes out, blog posts, documentation, information that you can find throughout the internet to give you explanations on how to troubleshoot things, we don't really tend to go back and update our documentation. So as you're reading older blog posts, even the Docker documentation itself, you'll still find information on Docker images. I think that by teaching you that legacy command, what it does, the information that it gives you, it's not too much of a leap for you to pick up the newer command. The same is the case with our docker run command. In order to create containers, we've been doing the docker run, and we've been using that hello world image. However, the updated command is docker container run. Now, we didn't have that in our system. It went ahead and pulled that down. Here you go. We have the same image we've been working with. We can do that docker image ls. And we can see that we now have hello world as well as our previous two images. But running containers is so much more than that simple hello world image. You know, that one was really written just to give us an output when that container is instantiated from our hello world image. But what if we're working on development? Like I talked about being able to create this image here. Let's go ahead and instantiate a container from our unnamed image. So that's going to be docker container run. I'm going to go ahead and clear my screen first so that you guys are, if you're looking at this through a tablet or a cell phone, aren't trying to focus at the very bottom of your screen. All right, so let me get my images one more time so I have that ID. Now, docker container run. There are a couple of flags which we'll be using here. -I for interactive, -T so that we can allocate a sudo tty. I'll go ahead and use the -- name flag so we can begin to learn how to name our containers. And I'm not very creative, so we'll simply go with Python container as the name. Now, I could do the entire image ID. However, it only needs enough information to be able to distinguish it from the other images. So simply a 3 or a 3.1 will work, as this doesn't have any other conflicts. Now we notice that my prompt has changed. That's because I am in fact inside of that container. So let's go ahead and see what version of Linux we're running. Now we should expect that we should be running on that Ubuntu 16.04 image, just as we suspected. Well, what about Python? Is it actually installed on this system? So if this build occurred the way that we told it to, we should also have access to Python 3. I can go ahead and just issue the command Python 3. And you'll see that I dropped down into the interactive command line for Python 3. Let me go ahead and exit though, because we're focused on the container, not on Python. And as a developer, let's say that I wanted to create a script just to ensure that it would work in this environment. I could exit out of this container and push a script into the container, or I can develop in here. Now I can use my command vim and then my script name. However, you'll notice that vim is not installed in this environment. And some of you may be saying, okay, so we need to update that onboarding image to contain vim. Do we really? Some of my developers may be using Nano. They may be using something else. Really, that's up to them, and we'll show you later how we can pull scripts into our container environment without needing to be able to write them in here. But for now, I'll go ahead and install it just for demonstration purposes. Note, this is for demonstration and development purposes and not best practices on how to use a container. Let's go ahead and create that quick Hello World script. And mind you, this isn't a coding class, so we're going to keep it simple here. I can go ahead and chmod my file. Oops, Python 3. There you go. Now that was kind of quick and dirty Python, but we know that my script can work inside of this containerized environment. Now, hopefully this example has provided you with kind of a view on why we would be using these containerized environments. Let's say that we had someone who was perhaps using Scientific Linux or maybe even Red Hat Linux, and they were developing on Python 2. Sharing this image and allowing them to instantiate a container from it and be able to run a script on Python 3, do some development or some testing, really wouldn't be a big deal. It'd be quite simple for them to do. In fact, we just did it. Okay, everyone, hopefully you now have a better understanding of how to interact and how to run your containers. Now, I did say that containers are ephemeral in nature. So in the next video, we're going to take the time to understand our container lifecycle, being able to understand really what we mean when we say that containers are intended to be ephemeral. Until then, though, you can go ahead and close out this video and continue on with your journey. Hey everyone, welcome back to our Docker Quick Start series, and in this video we'll be discussing the container lifecycle. Now, if for some reason you're not following along in order, I want you to go back and watch our Running Containers video. That's because this is a continuation of that. In that video, we went in and we created our first container that we actually went into. It was called our Python container. Inside of it, we created a Hello World script. And we went ahead and ran it. We ensured that Python 3 was working. But the question is, what happens when we leave that container? Is that container going to keep our script in it? Will we be able to restart it? How do we ship with this? This is all part of our container lifecycle. So today we're going to be discussing how we go from that image to running the container, to having that container stop, to being able to restart it. And what do we do with the development that we've done inside of that container? So let's go ahead and get to that command line and start getting our hands dirty. So we're going to kick things off by getting familiar with our environment. We'll do our Docker images command that we're used to here just to see the images on our system. We can follow that up with our Docker Container ls to see if we have any containers currently running on this server. And after that, we can do our container ls-a to see if we had any containers previously running that are now in a stopped state. So we can see we are in a brand new clean environment. So why don't we go ahead and create a container so we can start learning about the lifecycle. In order to run this container, we'll use our command docker container run. Then we'll use our similar flags that we've been using, our -i-t, and we'll run our Ubuntu 16.04 image that hopefully we've become familiar with. Once we type enter, we're in our container, and we can see that with our docker container ls command. So let's go ahead and jump to another terminal so that we can see that. And we can see here that we have a container running, and it's been named distracted diffie since we didn't provide a name. Have you ever wondered where these names actually come from? Well, let me just jump over to another screen here and I'll introduce you to the Moby project. Now, the Moby project is an open source project that was created by Docker to really help enable and accelerate software that is going to be containerized. Now, you can find this on their GitHub, and I'll link to the GitHub in the description of this video. Now, we're not going to spend a lot of time in this. This really is a deep dive concept, but since we haven't been naming our containers, I thought you might be interested in where the names were coming from. The Moby project was intended to be able to provide kind of a toolkit for Dockerized applications, for containerized applications. And I might want to note that the relationship with Docker is that they are an open source component of Docker. But if you go into Moby, then you go into the packages file, then name generators, namegenerators.go, you'll begin to see some of the names that you may have become familiar with. So it'll pull one from the string. You make it admiring, adoring, affectionate. So it's more of an adjective. So it's more of a descriptive name. And if we scroll down a bit, we can see that the second name that will get pulled comes from the second list. So you might get Alan, or let's say Austin. We even see the container name, which we pulled it as Diffie here on the screen. And if you have time, I'd really encourage that you spend some time reading through this list, and it's just a great compilation of really influential people in the technical community. But for us, it's time for us to get back to our Docker containers. So what happens if we exit this container? Will the container continue to run? Will it go into a stop process? Let's find out. And let's do our Docker container ls. We see that this container is no longer running. And let's go ahead and see if the container is in a stopped status. All right, we see that the container is in fact stopped. We can see distracted Diffie there. Let's go ahead and clear our screen so we can see a little bit more of what we're doing. So let's go ahead and do our Docker images so that we have a reference to which image that we used up on our screen that we can see. And you can see that we use our Ubuntu 16.04 image with the command docker container run. And what this did was it prepared our system in order for us to be able to instantiate a container, to start a container from this image. We went ahead and told it to run that Ubuntu 16.04 image, and when we clicked enter, we went from just starting a container to an actual running container. Our container was up and running until we exited out of that container. As soon as we exited out, it no longer needed to run the shell which we required for it to use, that bin bash shell that we see under command here, and it entered a stopped status. So we've kind of done our entire life cycle from, hey, we're going to start a container, to we're running a container, till we've stopped a container. So what happens if we still want to use this container? You know, we've decided that we want to make a few more changes to our configuration. We want to test something new. Then we can use the command docker container start. You'll then want to provide either the container ID, being that D66 code, or the container name, being distracted Diffie. We do our Docker container ls, and we can see that we have that same container up and running, distracted Diffie. And distracted Diffie has been running for a full 7 seconds, basically bringing everything full circle. We started our container with a Docker container run. Once we hit enter and told it that we wanted it to run that Ubuntu 16.04, our container was up and running. We then exited out of our container, which caused it to stop. And then we asked it to start that same container again, so we're back in that same cycle. Let's go ahead and clear our screen for a little bit more room. A Docker container ls will help us find our ID and name of our container. And I know it seems we're being a bit repetitive, but really doing repetitive tasks really does help you learn something new. So what happens if I want to be able to attach to this container again, though? Well, I can do a docker attach, and I could use the name distracted Diffie or just the ID, enough IDs to differentiate it from any other running container. So a D6 would be about all that I actually need. Now I've accidentally fat-fingered an enter here, so that's why we have our double prompt, but I can do something like ls, and you can see that our environment is indeed up and running. We can exit back out of this container, and as expected, we could do a container ls and see that this environment or this container is no longer running. Let's do our container ls-a, and we can see that once again, it's in a stop status. So hopefully you now have a better understanding of the container lifecycle. And I hope that part of you is wondering, okay, so how do we take our script and actually have it run within our environment? That's the questions that we'll get to in the next video. So go ahead and close this one out and continue on with your journey. Hey everyone, it's Elle Marquez with our Docker Quick Start series. This video, I'm going to try to keep it short and to the point. Now it's labeled container and image management, so that's what you're going to be learning in this video. You're going to be learning what to do with all the images that you no longer need, how to tell when a container is still running, what containers are currently stopped but still taking resources on our box. So let's go ahead and get to it and get to cleaning up our environment. So our first move, as usual, is going to be to get used to our environment. So let's do our Docker container ls to see what containers we have running on this system. We can see that we currently don't have anything. So let's do that Docker container ls-a, and we can see that I have 2 containers. I'd created another one for testing purposes earlier. And let's do our Docker images, and we can see that our 3 usual images. So what if I'm done with this at this point? I no longer need these containers. Well, in order to remove them, it's a simple command, docker container rm for remove. Then we go ahead and we put in the container ID, and I can just push enter and it'll remove that container. Let's say that I want to go ahead and remove both containers. Then it's a simple docker container rm again. And this time I could use the ID, or as I've gotten attached to using the name distracted diffie, I can go ahead and use that. Let's click enter, and distracted diffie is no longer with us. I could have also removed them both at the same time with docker container rm and listed both the container IDs, the name, or a combination thereof. All right, let's clear our screen, and we can do a docker container ls-a, and we can see that neither of these containers is available on our system anymore. All right, let's do our images command in order to be able to see what images are on this box. And we can see the same 3, but you know what? I'm done with Hello World. We've used that one enough times. Let's go ahead and remove it from our box. The command is docker rmi, that's remove image, and the image is no longer on our box. I could go through and remove the remainder of these images. However, if you recall, the image which we created, which is currently untagged, we really haven't saved anywhere outside of our Dockerfile. So what if I wanted to save it? Well, in order to do so, I could simply push up this image into the Docker Hub. So let me clear out my screen here so that we can see a little bit better. And I've pulled up our Lucid chart here in the corner for those of you that may be visual learners. So the first thing I'm going to do is I'm going to log into my Docker Hub account with the command docker login. Now I want to use the ID that we created previously in this series in order to create our Docker Hub account, which for me is lopunk. Same password as we used in our Docker Hub. And you can see we have logged in successfully. Let's go ahead and list out our Docker images so that I can grab the ID for the image that we created. So we're going to use the command docker tag, and then we'll give it the ID of the image that we created. So that's going to be that 311 number that I just copied. Then I'm going to let it know that I want it to go into my area of the Docker Hub. So you can think of me as perhaps a distribution that is giving out this image. So I'll be using lopunk. Please use your own here. Now my image is going to be tagged as an onboarding version 1 image. Later on, who knows, maybe I'll do some updates and I'll have an onboarding version 2. I will note that there is also another version of this command, which would be your Docker image tag. It works exactly the same. So let's do our Docker images. or you can do a Docker image ls if that's better for you. And that'll show you that our image tags have indeed been updated. So let's go ahead and push this up to the Docker Hub. So let's do Docker push. lopunk is going to be mine. Make sure to put your username in here. We're going to do a backslash, and I'm going to want to create a repository for this image, specifically for my onboarding image. So I'll just call it onboarding. It says here, this push refers to the repository docker.io/lopunk/onboarding. We'll visit that in the Docker Hub in just a bit. But I do want to take a moment here and look at what you're seeing on your screen. What you see is there were 2 image layers that were pushed to the Docker Hub. However, 4 came from the Ubuntu library. If you recall, when we looked at that Ubuntu image, it had 4 image layers. Those are the ones being copied from the Ubuntu library. After all, there's no reason to push them up if they're already there, right? And our 2 changes are what are being pushed up to our repository. If you don't recall what these changes are, let's go ahead and cat out our Dockerfile so we can see what changes we made. So you can see that we started out with Ubuntu 16.04. That's going to be your 4 mounted layers. Then we added our label. That didn't create a layer because it's just a change in metadata. Then we did our run apt-get update. That's going to be one of your layers pushed. And then we did our run apt-get install Python 3, which is going to be the other layer that was pushed. Let's jump over and take a look at this in the Docker Hub. So here in the Docker Hub, you can see that I'm logged in as the lopunk user. I now have an onboarding repository with my version 1 image. If I want to push up additional tags for this repository, let's say perhaps a version 2, it even lets me know how to do that. Now that I have my image in a safe place, I can get to erasing images. But let me show you one last thing. When I tried to erase these images, I tried to erase the Ubuntu image before I deleted that onboarding image, and I ran into an issue. The issue being that that onboarding image depends on that Ubuntu image for those 4 image layers. So while I still have it on my system, it wouldn't really make sense to delete it because I'd be deleting a portion of my image. Now that we've deleted that onboarding image, we can go ahead and delete our Ubuntu image. Well, what happens when I'm ready to create that version 2? What if I want to have version 1 as my inspiration? No problem. All I need to do is a Docker pull, tell it what repository, it's going to be lopunk. I want my onboarding version 1 image. And there you go. Our onboarding image is back on our system. So hopefully all of you did not find that too complicated. The great thing about Docker is that their help pages really do show us everything that we need to know. But for now, hopefully you feel a little bit more comfortable working around your environment and being able to clean up images and containers when they're no longer needed. Go ahead and close out this video and we'll continue on with our journey. Hey everyone, it's El Marquez back with your Docker Quick Start series. Now today we're going to be discussing Docker ports, or maybe more realistically, container ports, because the technology behind it and the concepts really kind of open up to any containerization product that you're using. So what we're covering today is the ability to have access to your container, perhaps from just the internal host, just the server or laptop that you're on, or when you're ready to publish those ports to the entire world. Now, a quick note before I disappear and we get to the meat of the subject. If you watched the previous Quick Start version of this course, note that ports and volumes were included in one video in one lesson. I've decided that it's best to split those up because I have a lot to say on both subjects. With that out of the way, go ahead and get your command line ready and follow along. So here we are logged into our system, and the first thing that we need to do is see what's available on our system already so that we don't get confused through the process of creating new containers. So let's do our Docker Container ls. Docker container ls-a, and Docker images, or Docker image ls. Now you see there really isn't anything going on in this system right now, so we really shouldn't have any conflicts when we're talking about port accessibility. So let's go ahead and clear our screen, and we'll start off with our usual Docker container run command. Now this time I'm going to use a -d flag so that this container runs detached, and we're going to go ahead and use a brand new image, and that's our Nginx image. This has a little bit more of a real-world practicality than our Hello World image or even the new onboarding image which we've developed. Once this is done, we can do a Docker container ls, and we can see that we now have a new container up and running, starting with a container ID of 06. Now, actually, since there are no other containers on this system, we could just refer to it as container 0. Another thing that you'll notice is that under our ports, we have port 80 available on this system. It's port 80 TCP, and it's available or exposed in the container. Now, the reason that I pause and kind of overemphasize the word exposed is there are two terms that you'll want to be familiar with. One is exposed and the other is published. Exposed opens up and exposes the port inside of the container and makes it available to localhost and internal services. So I'll be able to actually go into this container as usual, but I'll also be able to use services like elinks to connect to the container on port 80. We'll actually do that in just a bit. To publish a port, both the host port and the container port can be specified, and they're basically linked to one another so that we have accessibility to the container from the outside world. Don't worry, we'll use examples of all of this so you can better understand it. But what you need to understand right now is with this port, port 80, being exposed in the container, we could connect to it with services such as elinks. However, we could not connect to it from our web browser or using the public IP of the server. Now, how do you know what port's going to be exposed whenever you create an image? Well, you can use the command docker image history and then tell it what image you'd like to look at. So that would be Nginx. And we can see that port 80 is exposed on this container. So let's go ahead and clear our screen and see what this would look like. So let's do our Docker container ls so we always remember what container we're working with. I know we only have one now, but it's best to get into the spirit of being able to see all of the containers in your system before you start running commands. Then we'll do a Docker container inspect, and I'm going to grep out the IP address for this container. Now, as I said, it would be really helpful if we specify what container we're working with. So let's try that again and use our ID of 06. Now I see that this container is running on 172.17.0.2. So let's go ahead and do elinks to it. Now I could specify port 80, but as web servers by default run on 80, elinks does not require that. We can see that Nginx is in fact up and running. Now, if I tried to do the same command, however, and worked with a localhost instead, now you can see here that we're unable to establish a connection. That's because we don't have our localhost listening on port 80 running Nginx. So let's go ahead and try that command again. We'll do our docker container run -d, but this time we'll use a capital P option with our Nginx image. Docker container ls will let us know which container is running. Well, it would if we used a Docker instead of docket. But now that we have it going, we can see what occurred. So we have on port 32,774 of our host system being mapped to port 80 of the container. Now, if you've been using Linux Academy servers for a while, you know that that port really doesn't do us any good because we don't have access to it by the way that our servers are made. So what happens if we only have specific ports that we can use and we want to specify a port? Let's try docker container run -d, but this time let's do a lowercase p. Now we can say that we want port 80 of our host to be mapped to port 80 of our container. And I'll go ahead and use image httpd just to prove to you all that this is not another container that we've already created that we're able to connect to. Now, before I clear my page, I realized that I did miss a little bit of information here. Where did this port 32,774 come from if we never specified it? Well, this is the ephemeral port range, and it's typically a port between 32,768 and 61,000 that it's chosen from. Really just kind of depends what the IP local port range is set to as the kernel parameter within your box. But that's really more of a topic for a deep dive, so let's go ahead and clear our screen and see if we can connect to this Apache container. Now we can make use of a great tool by a good friend of mine, Major Hayden, and we can do a curl -4 so that we can get an IPv4 address to iconhasip.com. This gives us the IP of our box. Now remember, if you're following along, you'll need to get the IP for yours. And we can use an e-links to that public IP. And we could specify port 80, but as that's the default port for an Apache page, we can just go ahead and type enter. What do you know? It works. We get the default Apache page. Let's take one last look at our container LS to see what it is that we covered in this video. So we know that by the use of a lowercase p, we can specify what port we want to match to what port in our container. And we know that with our next container, we can use a capital P to have a random port chosen that will be mapped to a local port on our container. And finally, if we do absolutely no flags, we just spin up a container, we'll only have the port that was exposed in the Dockerfile for that image. Now, there's a lot more that can be done with Docker ports than what we've covered here today. That's one of the downfalls of a quick start, is that we really can't do a deep dive. So if you want to learn more about Docker ports, I'd really recommend that you go take our Docker deep dive course. For now though, you can go ahead and close out this quick start video and continue on to learn about Docker volumes. Hey everyone, we're back with our Docker quick start series. Now hopefully you will forgive me for staying off camera, but since this is the second of our redirection portion of our Docker quick start series, I thought it best just to get behind that command line and start talking about Docker volumes. Now we're going to start off the way that we always do, and that's by checking our environment. Docker Container LS, Docker Container LS-A, and our Docker images. Now we will note that we still have a few images on our system from our previous videos. However, I'm going to go ahead and allow these to stay on our system because we can use them when creating our containers for our Docker volumes. So let me go ahead and clear out my screen and we can jump right into learning a bit more about Docker volumes and how one would use them. Now, Docker volumes are the preferred mechanism for persisting data that's generated by a container, or that's generated to be used by a container. Docker volumes have several advantages, and that's, first of all, we can actually use them on both Linux and Windows containers. You can actually use volume drivers to let you store volumes on a remote host or even a cloud provider. And new volumes can have their content pre-populated by a container. Now, we're not going to go into these functionalities. However, I thought it was important to mention them to you in case you'd been wondering, is this only for Linux containers? Or do I have to use my host as that storage? So the one thing I love about Docker is how user intuitive they make their commands. To find out if I have any containers on this system, I simply use the command docker volume ls. I see that I don't have any on this system, so I can go ahead and create one with the command docker volume create. Now let's go ahead and create the volume that we see there on our Lucid chart, which is going to be our dev volume. And in order to see it, let's do that docker volume ls one more time. And there you go. We have a local volume that is a dev volume. Now perhaps this volume already existed on my system and I wanted to know a little bit more about it. I could use the command docker volume inspect. And I'd get additional information such as labels that were used when creating this, perhaps a created at date that might give me an idea. If we didn't use labels, that created date might give me an idea of what project it was created to work with. Let's go ahead and dig in a little bit into how we would actually go about using this container. And we can go ahead and start by mounting this volume into a container. Now I will note that originally there was a -v flag or -- volume that was a standalone for containers, and then there was a -mount flag that was used for swarm services. However, starting with Docker 17.06, you can actually use the --mount command with standalone containers. In general, the -mount command is more explicit and verbose. The biggest differences between -v syntax, it combines all of the options into one field, whereas the -mount syntax separates them. I'll use both in examples, one for our dev container 1, one for our dev container 2, so you can actually see what that looks like. So let's start out with creating a container. So Docker container run. Then we're going to go ahead and create it detached. Let's go ahead and name this our dev container. And we'll start off with our mount flag. So that's going to be --mount, the source of our volume, and that's going to be that dev volume. Now our target is where inside of this container is it going to be mounted. Now I'm going to be using Nginx, and we've been talking this whole course about creating that Hello World app, so I'll go ahead and mount it into app. And I'll use Nginx. All right, let's do our Docker container ls. We can see that we have a container up and running, and we can see if this volume has indeed been connected to it by doing a Docker container inspect. And we can see under mounts, we have the type as volume. Its named is dev volume. Its source is going to be that internal local storage located at varlib docker volumes devvolve data. And its destination is inside of our container in our app directory. And we can actually go into the container and take a look at that. All right, so we're going to be needing our sudo permissions, and we're going to do ls varlib docker volumes. And we can see our dev volume resides here. We can list out information inside of it. As we would expect, there really isn't anything in here. This really is what we would expect, is we only have that placeholder here, but we can actually go in to the container and create some data. Let's do that by using the Docker container exec command. Now we'll go ahead and execute an interactive terminal with a shell command. It would help if I use the command exec, not exect. So here we're logged into my container. We can do an ls, and we can see our app directory. Let's create a file in this app directory. We're just going to echo hello inside of hello.txt. We can do an ls inside of app and see our hello file is there. Let's exit out. And we can use that ls command to see what's inside of our volume data. See hello text. So what happens if we stop our container? Let's do a Docker container stop dev container, devcont. And we're going to go ahead and actually remove this container from our system. What happens now if we list out the data inside of that volume? It's still here. Let's create a brand new container, and let's do Docker container run. We're going to go ahead and create it in a detached mode as always. Let's go ahead and stick with our naming convention and name this container devcont2, dev element container 2. And we'll go ahead and use our -v flag now instead of our mount flag. So we're going to mount dev volume to app. We're going to use our Nginx image And there you go. We have a brand new container called dev.cont2, and dev volume is connected to that container. Let's go ahead and execute a shell into this container so that we can see if our hello.txt is there. Do an ls, we see app. Go ahead and list out what's inside of app. What do you know? Our hello text is indeed in this brand new container. Let's cat that out just to make sure that our data did persist. There you go, hello. All right, just for a few giggles and maybe to solidify this in our mind, let's go ahead and create a new file inside of this container. We'll go ahead and call this one goodbye, and let's just say goodbye. Go ahead and exit, and we're gonna list out those files inside of our volume one more time. And here you go. There is our goodbye text. Hopefully you have a better understanding now of how to start using Docker volumes. If you want to know more, I'd encourage you to continue on with our Docker deep dive course. For now though, go ahead and close out this video and continue on with your journey. Hey everyone, that's it. You're done. You've completed our Docker Quick Start course. However, if you're anything like me, you're already wondering what's next. What am I going to learn that's going to help further my knowledge or my career? Well, unfortunately, only you can answer that question. However, I am here to provide a little bit of guidance. Let's say you were taking this course and you kept thinking, how are we doing this? How are we creating these containers? Then I'd recommend that you take a step back and take my Essential Container Concepts course, which will go over concepts like namespaces, true-rooted environments, C groups, the technology that helped make containers a real product. But if you already know those concepts or you're just ready to learn more Docker, I'd recommend that you go in and take our Docker Deep Dive course. This will enable you to learn more about being able to mount volumes into containers or the ability to set up networking. Let's say that you're looking for a job right now and you really want to be able to prove that you know these concepts. Then go through and take our Docker Certified Associates course and gain the information, gain the knowledge that you need to know to be able to pass that exam before you go applying for a job. Let's say though that you're a big picture person and you want to understand, how do we do this in a production environment? How do we create these containers that I've been using on a massive scale, hundreds, thousands of them? Then there are two courses that I'd recommend. The first being that Docker Certified Associates course, because it'll introduce you to Docker Swarm. Or if you really want to know the nitty-gritty, then I'd recommend our Kubernetes the Hard Way course. Learn how to build your Kubernetes environment from the ground up to really understand how container orchestration occurs. Regardless of what you decide, do me a favor, drop by our containers channel on our community Slack and let me know that you finished this course and what you decided to do. Not a Slack person? No problem. Drop by our community message board and let me know how you've decided to continue your journey. Until next time, this is Elle Marquez with linuxacademy.com.